Hello, this is AAT, section 4.2, solving rational equations. A rational equation is an equation that contains at least one fraction whose numerator and denominator are polynomials. So this first one right here is actually, it is a rational equation, but there are no x's in the denominator. So this is no different than when we first started in Algebra 1 and had fractions. And there's two different ways you can do it. Some people like to change all these denominators to common denominators. I think it's easier to find the common denominator and multiply everything by that common denominator to eliminate the fractions. In other words, 3, 2, and 6 will all go into 6. So if I multiply this first fraction by 6, and you don't have to write them out like this, but I just want to show you on this one what I'm doing. And then the second, you got to make sure you multiply every single term by 6. So 2/3 times 6, we can cross cancel. 3 will go into 6 2 times, and we end up with 4x. 2 will go into 6 here 3 times, and we have 3x. And then the 6's cancel on the last one, and we have 5. And then it's just a very basic algebra problem. 4 and 3 combined in like terms, 7x equals 5, and of course divide by 7, and x is 5/7. So the other way to do it would be to change all of these to 6 first and then work with the fractions, but I prefer myself to get rid of the fractions first. So same thing here, but notice this one is truly irrational in that it has x's on the denominator. So we're going to do the same thing. We're going to think, okay, what's the common denominator? And we talked in the last section about for a common denominator, you need to be sure that you have the highest degree of the x's that are being represented. So we need at least one x, and we have to have a 2. And of course, this is just over 1. So we're going to multiply 2x times 1 over x. We're going to multiply 2x times 3 over 2x. And we're going to multiply 2x times the 10. Don't forget that. You have to multiply it times every term. So here the x's cancel, and we have 1 times 2, 2. Here the 2x's cancel, and we just have 3. And here we get 20x. So 5 is 20x. Divide by 20. And we get 5 over 20, which is, of course, 1/4. So be careful when you're solving rational equations with variables in the denominator. You might end up with solutions that do not work in the original equations. These are called extraneous solutions. As we go through these, I will point out when it's very possible to get extraneous solutions. They are not real answers. Always check your answers in your original equations. Now, you have to be careful. Sometimes plugging in these answers are actually harder than solving the equation itself. But there are certain circumstances where extraneous solutions are more likely to come in, and we'll talk about those as we go. Okay, so to solve rational equations, determine domain values that will create 0 in the denominators. This is where your expression is undefined. So like in this first, actually example 2, x here is never allowed to be 0 because you cannot have 0 in the denominator. Here, there's no x in the denominator, so we don't have to worry about that. But this is an excluded value, and sometimes it's important to think about that ahead of time, because if we got 0 as the answer, we would know that that was not a possible answer because you can't have 0 in the denominator. So get a common denominator of all the terms, set the numerators equal to one another, solve the resulting equation, and check for extraneous solutions. Here, after I get a common denominator, I prefer to multiply all terms by common denom. We're going to be doing that instead. I think that's a little time saver. So here, this one you can think of it as a proportion. If you have a fraction equal to a fraction, A over B equal to C over D. We know we can cross multiply, and A times D equals B times C. Cross multiply if you have a proportion, fraction equal to a fraction. And we could do that if we make this 3x minus 1 over 1. Or we can think of it as just a rational equation like before. The common denominator is, of course, x plus 2, because that's the only denominator there is. So if we multiply every term by that, the first term is this whole x squared plus 1 over x plus 2. So I'm not going to distribute it out this time. I'm going to multiply as I go. So on this first one, the x plus 2 would cancel, and I'd just have x squared plus 1. And then on this other side, I'd have 3x minus 1, nothing cancels, times x plus 2. Super careful here. If you are multiplying binomials, you know you have to FOIL that. Don't just multiply the first and the last. So we got x squared plus 1 equals first 3x squared, outer 6x, inner negative x, and the last is negative 2. So we got a quadratic here because this is an x squared, so we need to use the zero product property to get everything equal to 0 so we can factor it or use the quadratic formula. So I'm going to subtract my x squared over. I'm going to subtract my 1 over. And then I'm going to combine like terms. So now we got 0 equal to 2x squared. 6x minus x is 5x. And negative 2 and negative 1 is negative 3. Okay, so now we're factoring, and this is a trinomial with a coefficient in front of the x squared. So this is when we need to be super careful. We got 2x times x. The only thing that could be, well, I guess actually that's the only thing we could get to get 2x squared. And so we got 2 and 1 for the first, 3 and 1 for the last. We want to cross multiply. We get 3 and 2. Can those combine to be 5? Yes, if they're both positive. But if they're both positive, this would not equal negative 3, and that's supposed to be the last. So I'm going to flip around. 2 times 1, and 1 times 3, and that's 6, and 1. Now that can equal 5 on the inside if it's 6 minus 1. Which means this is 3 and negative 1, which would multiply to be negative 3. So that looks like those are my terms that are going to go in my factors. So I got 2x and 1x for the first, and negative 1 and 3 for the last. And we're solving this equal to 0, so we set each one equal to 0. 2x minus 1 equals 0. X plus 3 equals 0. Add 1, divide by 2. X is 1/2. And x is negative 3. Perfectly possible to get 2 answers. But let's go back at the beginning and double check what was our values that we could not have. Well, x plus 2 could not equal 0 because that was a denominator. So our excluded values would come from that. So if we solve x plus 2 is not equal to 1, if we subtract 2, x cannot be negative 2. Okay, but that's okay because we didn't get x is negative 2 as the answer. We got 1/2 and negative 3. Okay, flip it on over. So a little more to it. Now we have denominators that are truly unalike, not alike. So we're going to have to find that common denominator. So this first one, example 5, make sure every term's represented. Okay, so what are our terms? We've got here a 2 is a factor, an x is a factor, and an x plus 1 is a factor. So we have to represent with every one. Because this x plus 1 is all one factor on its own, this denominator, you can't just let x count as that whole thing. The whole point, remember, is to eliminate the denominator. So multiply this by all 3 terms, 2 as well. So if we multiply by the first one, the x plus 1s will cancel, but we're still left with this 2x times 2x. So the x plus 1's cancel, but we have 2x times 2x equals, got to multiply this 2, nothing cancels, so we're going to multiply it by 2x times x plus 1. On this one, the 2x cancels. Remember how I said when you're multiplying by something subtracted, change this to a plus minus, so you'll make sure to distribute that negative 5. So the 2x's are canceling, so it's negative 5 times the x plus 1. 2x's cancels, but the negative 5's left with x plus 1. Okay, so we got some distributing, some cleaning up to do. 2x and 2x is multiplication, so that's 4x squared. Here we have 4x times x plus 1. We're going to have to distribute on that and distribute on this one. So I'm going to just put a plus there, distribute my negative 5, and we have negative 5x minus 5. Still got to distribute here into the parentheses. So 4x squared equals 4x squared. 4x times 1 is 4x, and then we still have this minus 5x minus 5. Okay, so this is nice. These 4x's are going to subtract away. We subtract them from both sides. So now we have 0 on this side, combine like terms, negative x, 4 minus 5 is negative 1, and minus 5. Add 5 to both sides. Negative x equals 5, and divide by negative 1, so x is negative 5. Okay, let's go back and check and make sure it's not an extraneous solution. Our excluded values. And you may just be asked on a test, what are the excluded values? X plus 1 cannot equal 0, which means x cannot equal negative 1. And 2x cannot equal 0, which would give you 0 divided by 2. X cannot be 0. So those are the excluded values, but x is negative 5, so it's not a problem. So that looks good. Okay, now this one, a lot going on here. So here, to find the common denominator, we've got to factor to find the common denominator. And sometimes that factoring is going to be factoring a trinomial like this, but sometimes it'll be a GCF. So look for GCFs. Sometimes it'll be difference of squares, like I see coming down here. So if I factor this little thingy, this is two things that multiply to be 12 and add to be negative 8. What would that be? Yes, negative 6 and negative 2. Okay, so which is nicely the denominators we already have. So I can already see our excluded values. A can't equal 2, and A can't equal 6. Can't equal 2 from here, can't equal 6 from here, same denominators there. So when we're multiplying to get rid of all of, I'm just going to think of this as the common denominator. So I'm going to multiply everything by the common denominator, A minus 6, A minus 2. Because A minus 2 is represented for this one, A minus 6 is represented for this one, and of course we need both of them for this one. So now we cancel. On the first term, A minus 2 cancels, but we're still left with A times A minus 6. So A minus 2 cancels, but we're still left with the A times A minus 6. Plus, the A minus 6 cancels, but we're still left with 1, and I'm just going to write 1 there, times A minus 2. Of course, we didn't have to write that one. And on the last one, A minus 6 cancels, A minus 6 and A minus 2 cancel, so we're just left with 4. So that's nice. So now we distribute A squared minus 6A plus A minus 2 equals 4. So this is quadratic equation, so we have to use the zero product property, get it equal to 0. So I'm going to subtract 4 from both sides and combine my like terms. So I got A squared, negative 6A plus A is negative 5A, and negative 2 minus 4 is negative 6 equals 0. And gosh, this looks a lot like the one we had over here, but not quite. Okay, so we want two things that multiply to be -6 and add to be 5. So if we do 3 and 2, we'd have -3 times +2, or vice versa, would not become a -5. So if we do -6 and +1, those will multiply. So make sure the sign's going to work out. Equals 0, so we set each one equal to 0. We get A equals 6 and A equals -1. But notice what happens. A equals 6 is an excluded value. So this answer is extraneous. That's why it's so important to look and see what those excluded values are. So if it's going to make your denominator 0, you throw it out. Your only answer is A is -1. Sometimes we bring in a value that's not going to work. Okay, example 6. So common denominator. First factor everything. This is difference of squares. So that's x minus 2x plus 2. So I can see what my common denominator is. I got to have an x minus 2, and I got to have an x plus 2. Now let's go over real quick. What are our excluded values? Denominator can't be 0, so x cannot be 2, and x cannot be -2. So if we get that at the end, we need to make sure we get rid of those answers. So why don't you take a second, and I'm going to pause the video and try this. I'm going to try it too, and then we'll check. All right, and I got an answer of x equals 6. Hopefully you did as well. Things to be careful of. Did you change this 14 to a plus minus? So you made sure you distributed a -14 through this. That's a very common mistake. Then got everything equal to 0 using the zero product property here. And so you got x squared minus 12x plus 36, which factors to x minus 6, x minus 6. So the answer is 6. Not an excluded value, so we are A-OK, and we will stop there.